Hi everyone, today we're going to review how to solve 1 and 2 step equations. And then we're going to look at how to use those properties that we learned about last time to justify the steps in solving our equations. So let's do some review here. To solve an equation, we must isolate the variable. Isolate means get it by itself. We do this by undoing the operations in the reverse order of GEMDAS. And we call that undoing the inverse. So think about those inverse properties that we learned about last time. So solving equations in undoing order, in the opposite or reverse order of GEMDAS. We're going to call that SADMEG. So just like GEMDAS, we're going to combine that subtraction and addition kind of together and take care of undoing any of those first. Then we're going to look at undoing division and multiplication. And then we'll undo any exponents, and then we'll undo any grouping that we have. All right, so let's come down and take a look at some examples. So we're going to go through these 5 examples really quick, and then you'll have some to try on your own. All right, so let's start with this first one. So the first thing I always do is I draw my line through the equal sign. All right, and you're going to see keyword solve. So we've talked already about evaluate and simplify. Now we're bringing in that word solve. Solve means we have to figure out what is the value of the variable. All right, so the operation happening right now is division. So I need to undo the division. Well, the inverse of that would then just be multiply. So I am going to multiply both sides by 4. Now I always like to draw a line where I show my work and then my answers go below it. All right, so now that I have multiplied a 4, and then its inverse of 4, they cancel each other out. All right, so when we come down to the next line, we bring our b down, and then we do 12 times 4, which is 48. All right, and now my b is by itself. It's been isolated. It's finished. I can put a circle on my answer. All right, let's come over to here. This time we need to isolate m. So again, I'm going to draw that line through my equal sign. This time, I have to undo that multiplication again. But I need to figure out the inverse of 4/5 because I'm multiplying m by 4/5. So the inverse of 4/5 then would be its reciprocal. So remember, the inverse of multiplication is its reciprocal. So that means we're going to flip it over, and I'm going to multiply by 5/4. And then I'm going to do the same thing over here. Again, I just like to draw that line to separate my work from my answers. Once I do that multiplication here, cancels out those 2 fractions. And I bring my m down, and I do this multiplication here, which you can use in Desmos or in the graphing calculator. And we end up with 35. So m has a value of 35. Circle our answer. We're done. M has been isolated. All right, so those were both 1-step equations. Let's come over here and look at what happens when we have a 2-step equation. So I'm going to draw my line. Right? And what I like to do is I like to figure out where is my variable, because that's what I'm trying to isolate. So it happens to be this term has the variable. Well, remember our SADMEG. We're going to undo any subtraction and addition before we can deal with undoing that multiplication or division. So we have some addition to undo. So the inverse of adding 1 would be subtracting 1. So I'm going to subtract 1 from both sides, draw my line. Right. Those inverses, remember we learned last time, the inverses, additive inverses will combine together to make 0. It means we don't need them anymore. They cancel out. I'm going to bring my 3r down and do the math. 16 minus 1 is 15. All right, now we can take care of this division or multiplication. So I'm going to undo that multiplication by dividing. So I'm going to divide both sides by 3. And then I just like to draw my line. I'm not requiring you guys to draw these lines. I just like it to separate things out. My 3's will cancel each other out. And I bring my r down, and then 15 divided by 3 is 5. Circle my answer. Right. Once your variable is by itself on one side of the equal sign, you're done. All right, let's come down and take a look at this one. It's got a fraction in it again, so I know we get scared of those fractions sometimes. We don't need to, though. Okay, if we just remember what the inverse of multiplying is, it's just the reciprocal. We're dividing. Okay? So, draw my line. Once again, here's my variable. Okay? It involves some multiplication. So before I can do that, I'm going to follow my SADMEG, and I'm going to add 8 to both sides first to undo that addition. Those cancel out because they are additive inverses, so they combine together to make 0. I'm just going to draw my line. My 2/3 x is going to come down, and then 18 plus 8 gives me 26. All right, now once again, we're multiplying by a fraction. So the inverse of multiplying technically is dividing. But since we can't divide by a fraction, we multiply by its reciprocal. So I'm going to multiply by 3 over 2. Multiply this side by 3 over 2. Multiplying the inverses, cancel them out. So I'm just left with x on this side. And then 26 times 3 over 2 gives me 39. My variable is now by itself. It's been isolated. I'm done. I'm going to circle my answer. All right, now this one here is a little trickier, so we have to be careful. Let's go back up to our SADMEG here for a minute. So we have our subtraction and addition, our division and multiplication, our exponents, and then our grouping. So when we come down here, remember this fraction bar can act as a grouping symbol. So we have a group up top, and then we have a group on the bottom. Well, I'm not going to touch this group up top because that's going to be the last thing I deal with. So instead, I'm going to deal with the division and multiplication first. I'm going to deal with this division. So in order to undo that division, the inverse of division would be multiplying, or the reciprocal of 3 being on the bottom now puts 3 on top. So I multiply both sides by 3. That cancels this out. Oh, I forgot to draw my line in. Let's get that in. Okay. And now this group that I had on top will now come down to the next line. Okay. And then 3 times negative 12 is negative 36. Now I can deal with this group. And now the group is gone, and I can just undo that subtraction. And we know we do that by adding. Draw my line. Okay. These are additive inverses, so they cancel each other out to make 0. So just my x comes down, and then negative 36 plus 7 will give me a negative 29. X has been isolated, it's by itself. Draw a circle around my answer. Okay, now you've got 5 examples here that I'd like you to try that are just like the ones above. So go ahead and pause your video now. Okay, when we come back to class, I will post up those answers so you can check to see how you did. All right, let's go over to the next page. Next, we're going to talk about set builder notation. So while solving 1 and 2 step equations is review for you guys, set builder notation is something new. Set builder notation is just a fancy way of writing our answers. So it looks like this. We're always going to have a bracket, and then whatever variable was used in the problem, and then we use that variable again. And we read this as the set of x's such that x equals, and then whatever we got as an answer. Okay. So if we look back to the first example that we did, our answer was b equals 48. So instead of x, I'm going to replace those x's with b's. So I'm going to write my set builder notation. Oh, it's not wanting to pop up. There we go. Like this. So the set of b's such that b equals 48. So we're really just taking our answer, b equals 48, and we're building the rest of this around it, putting the brackets and that little line and the extra b. That's all that really is. All right, now we've got m equals 35 was our next answer to the next example. So when we go to put that in, again, here's my m equals 35, and then I just build around it. I add my brackets and that m such that. Nothing else really changes. All right, the one for C was r equals 5. So here's my r equals 5, and then I add in the brackets and the r such that around it. D had an answer of x equals 39. So here's my x equals 39, and then we just build everything around it. Now be careful, because if the variable happens to be on the right side of the equation, we do need to make sure that we flip it around so that the variable is always first when we write it in step builder notation. And then our last one was x equals negative 29. So again, x such that x equals negative 29. All right, now go ahead, pause the video now, and I want you to go ahead and do these 5. So pulling from the try on your owns from the previous page, put your answers now into step builder notation. Pause your video now. Okay, welcome back, and we'll put those answers up again when we are back in class. All right, now we're going to take those properties that we learned last time, and we are going to justify our steps for solving an equation. Now we're going to be really careful here with how they've done some things, because it might look a little different than what we're used to doing. All right, so we are started with this problem. 74 is equal to 8 plus the product of 3 and v. So here's the work for solving that equation. All right, we're now going to go through and identify the steps that were used. So what they did here, that's a little different than what you might be used to, is instead of, we know we need to subtract this 8. We want to get rid of we want to isolate this v, but it's all combined with the 3, so we have to subtract out the 8. Well, they show their subtraction, in line with the equation. Okay? They're showing their subtraction in line with that equation. So instead of going down below, they're just putting it in line like that. So that's what's going on here. So I'm subtracting 8 from both sides. Whenever something happens on both sides, that becomes a property of equality. And in this case, it's a subtraction property of equality. All right, well now let's look to see what changed from this line to this line. Well, now we can see that these two here, the 3v minus 8, got flipped around. Now it's negative 8 plus 3v. They did that to put these two together. Okay? So remember, when we switch the order, that's just our commutative property of addition. Okay? Now, let's see what happened next, what changed. So 2 things changed. We went from 74 minus 8 down to 66, and then we went from 8 minus 8 down to 0. Both of those, we could use what we call that substitution property, where I substitute an answer for a problem. And that's exactly what we did here. We substituted. This one, we have a more specific property. So if I add 2 numbers that are the same, and remember, subtraction is the same as adding a negative. If I add 2 numbers that are inverses, we get 0. So that's our additive inverse property. So this one here we'd identify as substitution. This one we would identify as additive inverse. So I actually have them both listed, substitution and additive inverse. Okay, now let's come down here and see what happens next. So in the next line, from here to here, my 0 disappeared. Really what we just did was we just added those 2 together, and we got an answer. So technically we would call that substitution, but we have a more specific property that we want to use here. So anytime I add something to 0, I get the same value. We just call that one the additive identity. All right, now we're down here. All right, so now our next step was to divide both sides by 3. So once again, whenever you do the same thing to both sides, it's one of our of equality statements. So in this case, it was division of equality, or division property of equality. And then they just call this our solution. but also we can say that we had the multiplicative inverse to get us from here to here. And we also had substitution, 22 from this here. But since they just labeled it automatically with solution, we're done. Okay, so we're just going through and basically naming the properties that were used in each step of solving that equation. All right, so now I want you to go to the next page, okay? And I want you to try this one on your own. And this will be the last portion of your notes. So once I'm done, you can turn the video off. So go ahead, complete this on your own. You can turn the video off now. I'll see you guys in class.